Great. Well, welcome. Everybody ready to launch? Awesome. So, what I'm going to tell you, I think most of you would probably agree that the future that I'm about to tell you about is possible. I think that by the end of the presentation, you may even think it could be probable. I hope by the end you may think it will even be inevitable. And we'll talk about this, but space is something that captivates us. It's something that really inspires us. It goes to the very essence of human curiosity. The same reason that our 6-month-old crawls around that new corner wanting to know what's there. That is what space represents to us. And, for literally since the dawn of humanity, for tens of thousands of years, people have been exploring the Earth. They've gone from Africa to begin with, and we've basically covered every corner, every nook and cranny of our globe. But we've only really explored in depth the Earth. And there's a great quote by one of my favorite people in history, Dr. Tsiolkovsky, who was certainly one of the founders of rocketry, discovered the nature of rockets and the rocket equation, that we live in this cradle. The Earth is our cradle, but we can't stay in the cradle forever. And if you think about it, throughout our evolution of exploration, only the last 50 years or so, 55 years almost, have we really even started to go to space. It's amazing to have been alive during the time when people can actually go to space. And it actually started relatively quickly. On April 12th, 1961, Yuri Gagarin became the first person to go to space. And by July 20th, 1969, which is only 8 years later, Neil Armstrong and Buzz Aldrin were standing on the moon. That's pretty amazing. In only 8 years to have gone from having no one in space to people on the moon. Now, what's a little bit depressing is that the last Apollo missions left the moon in 1972, and we haven't been back. And that's disappointing. I was actually born in 1974, so I was born after the last Apollo mission left the moon. But that beginning of the space age, the space race, really inspired a lot of people. And it did a lot of great things and certainly gave us the capabilities to be able to dream like we do now and to be able to try to make those dreams into reality like we're doing now. But over the years, there have only been 543 people who've ever been to space. Over 55 years, that's only about 10 per year. It's not that much. But I think over the next 50 years, that number is going to be in the millions. It's going to be fundamentally and exponentially better and different than it has been, and I'm going to tell you why. But let me tell you about me first, a little bit, just so you have some context. So I grew up again, from a pretty young age. I wanted to be an astronaut. I was sure of that. Unfortunately, by the time I became a teenager, it became quite clear that I wasn't going to be working for NASA because I had horrible eyesight, and it was far beyond the super stringent requirements of a NASA astronaut at that time. So I decided, well, if I can't go to space myself with NASA, I either have to figure out another way to go, or I got to help humanity get there by learning how to build rockets. So I went, studied aerospace engineering, so yes, I am a rocket scientist. And I started a company. Co-founded it with a gentleman by the name of Peter Diamandis, who I'm sure many of you know. He's actually spoken at this conference either a year ago or a couple years ago. And that company's goal was to take private citizens to space, to be the first space tourism company. And 20 years later, we're still the only company that's actually taken private citizens to orbit. There are some that are working on suborbital flights, and we really have only done a few flights. We've had 9 customers, 10 customers. So it's not really an industry. We've done a lot to change the mindset. A lot of the people that have gone to space with us have been people who had medical conditions that we got fixed. And so we sort of changed the mindset that you have to be some sort of, incredible fighter pilot to go to space, like the right stuff that I think a lot of people thought. But in terms of the technology, getting to space is still damn difficult. This pesky little gravity well we live in on the Earth, which I'm going to show you a video on in the middle here. And getting out of that gravity well is a real pain, and rocketry is really hard. There's a lot of people now, Elon Musk's, another who I'll talk about at the end, I've got a special comment from, who's also building reusable rockets, and they're solving that part of the equation. But what I'm going to tell you about now is going to solve the other part of it, which is how do we really open up deep space and the area beyond Earth orbit. So about 9 years ago, Peter and I were sitting down, and we were trying to figure out, well, tourism's not really going to do it. How do we really catalyze the opening of space? So we looked at history. And if you look at history, it's actually pretty amazing. Most of the exploration that's been done in history, whether it's the Silk Road 1,500 years ago that began to open the routes between East and West, the settlement of the Americas, certainly the opening of the American West, these were all driven by resources. They were driven by people who were searching for gold or spice or prospectors or better farmlands for food. And the development of resource is something that has driven almost all of our exploration and development, and really, frankly, allowed us to grow and prosper and elevate the level of human prosperity over the last several decades, certainly throughout the Industrial Revolution in the last couple hundred years. So that's what's going to drive the development of space, is resources. I'm sure of it. And so once we figured that out, we figured out that it was resources that would drive space development, that it would be a catalyst for opening up whole new economies, and it would be a great business. It's just going to take some time. We started a company, and so that company is called Planetary Resources. Peter and I founded that. We are operating. We've got a plan. I'm going to tell you a little bit about what our progress is, and we're getting there. And that industry that hopefully we've helped start is really going to drive the space economy of the next 50 years. So the mission of Planetary Resources is pretty simple: expand the economic sphere of influence of humanity into the solar system. Right now, our sphere of economic influence ends in Earth orbit. You could argue that we've done a pretty good job of putting satellites up there to communicate and check the weather and bring us DirecTV and things like that, but it ends there. But there is so much more out there. The resources on Earth are a crumb compared to the resources available even within our own solar system, let alone what's beyond. It is unfathomable how much is out there waiting to be accessed. And government cannot do it on its own. It must be commercially driven. For the same reason that the Cold War led to the space race, and when the Cold War subsided, government spending and going to the moon and things like that didn't become a priority, it has to be commercial. There has to be a commercial engine. So when we looked at resources and we knew we had to generate a commercial engine, we said, okay, what are the best resources in space? What are the most easily accessible? How do we get to them? What's on them? So what you see here is a graphical representation of time over the last 15 or 20 years. And you see the number of flashes that add new yellow dots. These are objects in the solar system. Those yellow dots are growing because we're discovering more and more of them. And most of what's in the solar system in terms of those objects is actually asteroids. So there are 100 million asteroids in the solar system. 100 million. And these asteroids are remnants of the early solar system. They're very pure. They have elements on them that are extremely valuable, not only on Earth, but especially in space. And so there's a very special breed, if you will, of asteroids that are going to really be the stepping stones to space, because we can't go after all 100 million at once. Turns out there's a group of asteroids that you may not know about. They're called NEOs, near-Earth asteroids. They are actually asteroids that orbit the sun in the same general way we orbit the sun. So it's kind of like driving on a racetrack with a car that's going fast next to you. The relative velocities of them are quite similar. And so it's actually really easy to get back and forth from these asteroids. And there are now, as of today, 13,896 of these near-Earth asteroids. The largest one is 30 kilometers. It's the size of a city. 800 of them are more than a kilometer in diameter. But the really interesting thing is that even the small ones, the 100 or 200 meter diameter asteroids, have enough materials on them to be incredibly useful. For example, a little icy rock that's 150 meters in diameter has enough ice, which you'll learn in a minute is actually rocket fuel, to have launched every rocket that's ever left the Earth since the history of the space age. And there's thousands of those, not to mention the big ones. So what are we talking about here? What we're really talking about, if you take the earthly analogy, is that these are the little coastal islands of space. These are the islands that we can jump to jump off to bigger and better places. They are the stepping stones. I call them gifts from nature. Kind of like it's a gift that a bunch of dead dinosaurs gave us fossil fuels and helped us elevate human prosperity and drive the Industrial Revolution. That was a gift from nature. These asteroids, the near-Earth asteroids, are absolutely essential to us being able to build and colonize the solar system. So let's talk about what they're made of. All the good stuff. You've got volatiles, oxygen, hydrogen. The very best rocket fuel is oxygen and hydrogen. That's what the space shuttle main engines ran on. It's the most efficient. But they've got industrial metals. They've got cobalt and nickel and iron and all the stuff you would use to build structures in space stations, even cities. And they've got really valuable metals like platinum group metals. And an interesting tidbit that you might not know, platinum group metals actually don't really exist on the Earth's surface naturally. Because when the Earth formed, the platinum group metals being very heavy, platinum is 21 times the density of water, for example, sank to the core. So when we mine platinum on Earth, those are actually sites where asteroids impacted the Earth. The concentrations of platinum group metals in asteroids are sometimes 1 billion times what you'd find in the best places on Earth. So these are really valuable materials. But let me explain to you, let's turn the volume up.
Imagine that you're on a road trip from Seattle to New York City. Now, what if there were no gas stations along the way, and you had to bring all the fuel that you'd ever need with you? You'd have no room left for anything. Well, in outer space, the problem is even worse than this. After all, judging by the space race of the 60s and 70s, you might have thought we'd have colonized Mars by now. But we haven't. We're trapped at the bottom of Earth's gravity well, which is so deep that escaping the first 300 kilometers takes more energy than the next 300 million. It takes 50 kilos of propellant to deliver just 1 kilo to Leo. But 4 more would get you the next 35,000 kilometers. And 2 more, the last 300 million to Mars, to the asteroids, to anywhere in the inner solar system. But those 4 kilos to Geo each need 50 kilos to get into Leo first. And those 2 to everywhere else each need 4, which each need 50. This exponential nature of the rocket equation has us stuck hugging our planet. Planetary Resources has had a Copernican shift in thinking. Travel beyond Earth's gravity well is nearly effortless. So, if fuel is sourced from space for space, we can avoid this exponential problem altogether. Fortunately, rockets run most efficiently on hydrogen and oxygen, which is just electrolyzed water and exists in near infinite quantities on asteroids. These future oil fields of space are also ultra-high-grade precious metal mines that lie unperturbed as the low-hanging fruit of our solar system, energetically closer than the moon, just waiting to be harvested. Mining asteroids could provide a fuel source 1,000 times more efficient than the brute force bring everything with you approach used by the Apollo moon program. So how big is the space market when economics improve by 1,000 times? No one knows for sure. But neither did the Wright brothers at Kitty Hawk, nor IBM or Bill Gates at the dawn of their new markets.
So I think that explains it pretty well, that this exponential and mathematical problem we have of how difficult it is to get off the Earth makes it very difficult to go beyond just getting into orbit. And if we can source fuel from space, for space, it exponentially changes the equation. It's an order, 3 orders of magnitude, if not more, in difference. That's what we're doing. That's the defining problem of what asteroid mining will enable. And all the stuff that I'll talk about in the last couple slides in the future is all enabled by that ability to create these fuel depots, the gas stations of space, and put them everywhere. put them in Earth orbit, put them in the moon's orbit, put them all around the inner solar system so that we can operate and send millions of people and all these materials around and use them to define and build a space economy. Now, the real interesting part of this is that ultimate goal is to build a self-sustaining human presence in space forever. That would make us multiplanetary. That would mean that we are now not just creatures of Earth. We are of space. And that's one of the top things I can think of in the history of life. And that could happen over the next 50 years. And that's what this will help enable. So I give you a quick view on the roadmap for where we are. As a company right now, Planetary Resources is in the prospecting stage. Just like resource companies today, first go out and look for the resources and where they are and how to get to them. That's what we're doing right now. We have a fleet of spacecraft called the Orchid line, and we're launching them one after the other. We've had test launches already. We're launching another one this year. This is the one in the lab right now. You can see they're actually quite small, these early ones, but they're extremely capable. These vehicles have advanced sensors, hyperspectral, infrared, optical. They use laser communications. I mean, really good stuff, really good stuff. And as they go to these asteroids in swarms, think of droids that go out to all these great targets and send back all this data. We'll find out exactly where these elements are. We will know everything about these asteroids before we send the missions there to begin to extract them. The red parts in this graphic right here are water, ice. So you might ask, okay, how are you going to, it's fine to go there and prospect them, but how are you actually going to turn them into fuel depots? Well, it turns out that the work on that's fairly straightforward. I know that may sound funny, but to turn ice into liquid oxygen and liquid hydrogen, there's a process that's been used for at least a couple of decades called high-temperature electrolysis, which is fairly efficient. And one of the great things about space is that you have this really good heat source. It's called the sun. And you can use solar energy to drive all of this. So number one, all these vehicles and these mining and prospecting spacecraft will be autonomous, driven by software and AI. Number two, they'll be using solar energy. Those are the two biggest costs of resources and resource extraction right now, manpower and energy. You get them for free in space, which is fantastic. So a lot of people ask me also, well, is this legal? Like, who owns the stuff that you would take off an asteroid? There hasn't been a lot of work in this area until recently. The defining legal treaty for space is the Outer Space Treaty of 1967, which really didn't address the issue of resources in space, but defined the characteristics under which private companies could operate in space. And so, amazingly, and I say that tongue-in-cheek, it was a lot of work with a lot of companies and working with the U.S. Congress, but President Obama signed a law back in November that was passed by Congress that set out a legal framework where private companies could own the resources that they take from these asteroids. And that was really the last big cog in the wheel, the step that we needed to be able to get the investment that we need so that these investors who would go and help finance these missions would know that they have certainty in that area. And there's now many other countries that are working on this in Europe, in Asia, and I'm sure over the next couple of decades, people will approach it in slightly different ways, and there'll be some big consensus on how to handle it. But it's legal now, and it's happening. And this is a big deal. So what happens then when we start to mine these asteroids, just to get to the really futuristic stuff? Well, first of all, we're going to start with gas stations. So we call them fuel depots in space because it's not gasoline, it's hydrogen and oxygen. But these fuel depots make it easy to move everything around, everything, including other fuel stations, right? So the other big part, though, is that, as I said, these are all autonomous vehicles. They're robots. And so they follow Moore's law. As computing power increases and artificial intelligence and autonomous systems increase, you'll have satellites that can use the materials and energy from space to build bigger satellites. You'll have bigger satellites that can use the energy and materials from space and the software sent from Earth to build colonies, space stations. where people can go. And you'll have 3D printed, by the way, this picture down here on the left is actually a 3D printing using powdered asteroidal material, otherwise known as a meteoroid, that we did in our lab. We have a partnership with 3D Systems. And so we've actually done a lot of this stuff in our lab on Earth. But you'll have machines building machines that build bigger machines using the resources in space, setting things up so that millions and millions of people can go there. And I have absolutely no doubt that over the next 30, 40, 50 years, maybe sooner, we're going to see multiple space stations, self-sustaining colonies, cities on Mars, cities on the moon. The sky isn't the limit. And it really is going to be something that changes humanity fundamentally. So we'll go back to the rocket equation. The inventor of the rocket equation, Tsiolkovsky. The Earth is our cradle. We've stayed in it for a long time, but it's now time to leave the cradle. And I'm a little bit over time, but I got permission to give another minute here because I just wanted to point out something else. I alluded to another individual who's in this industry, a gentleman you might have heard of by the name of Jeff Bezos. So Jeff is a friend. He runs Amazon. He also has a space company called Blue Origin. Now, just yesterday, funnily enough, he hosted a tour of reporters, which he hadn't done in years there. And there's an article, if you want to Google it. I didn't want to tell you before because then you'd be doing it during my talk. But it's on GeekWire. And here's some of the things he said. And I emailed with him this morning, and I got his permission to talk about this. So he said, space is chock full of resources. He sees in the future an inversion in flow of manufacturing of goods, where goods will actually be produced and heavy industries will happen in space and return materials to the Earth. And so the funniest thing he said, which I thought was great, he said, I'd really like to see the Earth zoned for residential and maybe light industrial. And the rest of it should be in space. And I agree. So I couldn't have said it better than that. We're not going to stay in the cradle anymore. It's time for launch, and the universe awaits. So thank you very much.